Alright, so this is a video about the basics of linear law, a chapter in additional math. So basically we are talking about having a non-linear expression and changing it to a linear expression, and then talk about the straight line relationships about it. So when we talk about straight line, basically, if you recall coordinate geometry, we have y equals to mx plus c. So important things to take note are that the variables y and x, like your vertical axis and the horizontal axis, are all variables only. Okay? And more specifically, when we talk about the variable on the vertical axis, it must have, or it should have, a coefficient of 1. Okay? For this one, it doesn't matter. And when we talk about m and c, which are very similar to your coordinate geometry, gradient and y-intercept, these two are actually just constants. So when we talk about constants, we mean that they are just numbers only. Okay, they should not have any x or y variables in them. So basically now we're going to go through a few examples about changing or reframing how it looks, a non-linear expression looks like, into possible linear expression. So if you look at this, so there are a few conditions to be satisfied, right? First of all, this y value, the vertical axis, has a coefficient of 1. As you can see, that's already satisfied. Down here is a combination of a constant and a variable. And finally, this one is a constant, no variable. So if it's obvious that it can be written as a y equals mx plus c form. If you cannot see it, I'll just rewrite it more clearly like this. So there you have it, y equals to mx plus c. Coefficient 1, purely a variable. So now you can clearly see that y will be the vertical axis, 1 over x will be the horizontal, the gradient m will take on the value of a, and the y-intercept c will take on the value of b. Let's move on. So now let's take a look at this example. X and y here, they are both variables, the coefficient is 1, so I can leave it alone. Then I take a look at here, a and x, okay, looks like m and x, and finally a constant b. So yeah, I can leave it alone. So basically I'll just rewrite it to make it clearer. xy is basically a times x plus b, and hence the y equals to mx plus c. So the vertical axis is a variable xy, the horizontal axis will be x, and a and b will be the gradient and y-intercept respectively. Now, if we go on to this one, again check the conditions, coefficient of 1 here, yes. A and x squared, okay, fine. But you see the last term here, or in fact both terms have variables in there. So we can't have that. We've got to change the expression in some way such that I'll at least have one term here that has only a constant. So I'm going to divide by x throughout every single term in the expression, or rather the equation. So I'm going to get y over x here. Ax squared divided by x will just simplify to ax, and bx divided by x will give me b. So there you have it, y equals to mx plus c. So vertical axis is y over x, horizontal axis is x, and the gradient and y-intercept. Okay, moving on. Again, always check coefficient 1, okay, a and a variable, but again, two terms with variables in them. I must have one that's variable free, okay, so to speak. So how do we modify this equation such that one of them doesn't have a variable? Yes, okay, you're going to deal with this fella over here. Basically, I'm going to multiply by square root x throughout. So think carefully, every single term multiply by square root x. What will I get? I'll get y times square root x. Now, you apply your laws of indices. A times square root x times square root x. What is that? Yes, okay. Square root x times square root x will just give me x actually. And when I multiply these two together, I'll just have b. So there you have it. Y is equals to mx plus c. So vertical axis y squared x, horizontal axis x, a and b respectively. Now last but not least, this one definitely doesn't look like two terms, okay, where I have mx plus c. So I'm going to have to do something first. Yes, I'm going to cross multiply, or rather multiply by the term expression ax plus b on both sides. So I'll have y times ax and y times the b equals to 1. So now I'm going to do a minor rearrangement. I'm going to do this. Okay, first by, just rearrange it, and I'm going to bring this term over. So I'm subtracting both sides, so 1 minus y ax. Okay, actually this is not the best way to represent it. Maybe I'll just rewrite it again. Negative axy plus 1. Why did I do this? Can you see that now I actually have almost y equals to mx plus c? Just one more step. What is that? Yes, okay, the coefficient of this y expression, the vertical axis, has to be 1. So I'm going to divide by b throughout. So complicated expression, but not to worry. So negative a divided by the b, I'm going to get negative a over b. Then I have my xy plus 1 over b. Now this looks very, very ugly, but you look at it very carefully, it is still y equals to mx plus c. Okay, this is 1 divided by b will still be a constant. So my vertical axis will be y, my horizontal axis will be xy, my gradient now is a not so nice looking expression, negative a over b, and finally my y-intercept will take on a value of 1 over b. So that's the basics of actually converting a non-linear expression into a linear form, so that we can do certain results and solve the questions that come in this chapter.